Okay, good morning, everyone. My name is Rich Banville, and I have with me Tim Sargent. We're both from OpenEdge Development, the home office in Bedford. And we're going to talk to you today about some of the projects that we're doing over the next few releases to help you achieve 5 nines. For those that don't know what 5 nines are, it's 99.999 uptime, right? And that means, 5 minutes and 23 seconds thereabouts, or whatever. A little less than 5.5 minutes, yes. So my introduction is longer than your downtime is going to be allowed for the year, right?
Set your watch.
Yeah, so it's really difficult, to achieve that. And but there's a lot of things that we're going to put in place over the next few releases in version 12. Our 12.0 release was really focused around performance, among other things, but really focused on performance. And our next few releases in 12 are going to be focused on achieving 5 nines for you. So we look at this 5 nines. It's really, we talk about it as continuous operations, right? And continuous operations isn't just a database thing, right? There's more to it than not needing to bounce your database. It's really about keeping the application up all the time. It's about, doing rolling upgrades to both your operating system and to your release of OpenEdge, schema changes, all kinds of things like that. And in a disaster, you still need to be able to continue to run your deployment, your whole deployment, your application. So it's not just a database thing. It's all these things working together. So I have here a chart or a list of different things that we need to address in order to achieve 5 nines. And mostly from a database perspective. I'm going to talk more from the database perspective on this. Tim is going to take over in the second half of this presentation and talk more from the application and schema upgrades, that type of thing, side of the house. So from a database perspective, we have a lot of different parameters that you can tune, right? And some of these you need to bring the database down in order to change them. Again, something that we cannot allow in 5 nines. So what we're going to do is allow you to change all of the database parameters while the database is up. And so when I say all of them, I mean all of them, with very, very few exceptions. Maybe something like -I, we might not support you flipping -I while the database is running. Well, I'm just saying there are some that we might not support. But for the majority of it, we are going to allow. Even like a -R, which would be finding how do we do that? Well, maybe we don't do that at the database level. Maybe we do it at the tool level. So if you want to run a binary load, we lock the table, and you can run that with a -R. Right, something like that. So we are working those out, and I'll talk a little bit more about that as we go through here. And the other thing we need to do is improve the way that you do physical maintenance on the database, right? And this includes extent management, includes truncating things like truncating areas. All this now needs to be done online, as well as table reorgs, index reorgs, any type of index maintenance, index rebuild, these type of things all have to be done online. And our goal is really not just to allow you to do it online, but to allow the application to continue running while these events are occurring. Not like the current table move that has a lock on the table and you can only do read operations while that's happening. We want to allow this, the application to continue running while we do this. And lastly, we'll talk, Tim's going to talk about schema maintenance, but there's also this, we need to make sure that clusters work properly and failover works properly, not properly, but I mean quickly for the application, right? So you want to be able to fail over to your target when you're using replication, but that failover and transition from a target to a source needs to happen really, really fast. We can't bounce that database and bring it back up because we're going to eat into too much of our 5 minutes for the year. Okay, so we'll talk about what we're doing in that area. So let's talk a little bit about the parameters, what we've done. And I will say that everything in this presentation, we do have target release dates on it. This is expected release dates. Again, the standard disclaimers apply. Something could change our direction, but for the most part, you can trust what we're saying in this presentation. So we look at all of the database. We call them the algorithmic modifiable parameters. These are things like changing dash spin, right? Something that doesn't require additional resources, really just changes the way the algorithms work. This work has actually been completed and is in the 12.1 release train, which should be out. I think we're targeting around August for release date of 12.1. And so if you look at, there are basically two ways to change these parameters. We did get rid of the startup parameter virtual system table. That's no longer available in 12. That was a column-based mechanism and not very expandable. And now there's like over 84 parameters now that you can change online through this. So this is a row-based thing. So you look at these, just do a find on whatever parameter you want, and then you can update the value associated with that. We also updated Promon, and if you know in Promon right now, there's a few parameters that you can change, but they're spread out all over Promon. So what we did was consolidate it into one screen, and so all of those updatable parameters now can be done from this one screen in Promon as well. So you can do it programmatically, or you can do it through the tool. There are some server-based parameters that don't make sense to automatically change while the system is running. And so they'll only be available for new servers that start or available to be changed on the primary broker only. I think in the future we'll probably change that so you can change it for secondary brokers, but right now we don't have a mechanism to change it for others than the primary broker. And these are a couple examples. Obviously, changing SSL while users are connected is not going to be able to communicate too well if someone's expecting encryption on one side and stuff's not being sent encrypted on the other side. There are parameters that require resources in order to modify, right? And in order to change those, you do those through this increase to option of ProUtil. And when I say they require more resources, often they need to have additional shared memory segments because you're growing the size of things. We already support a bunch of things through this mechanism like -big B, -L, those types of things. But there's a bunch that we don't. And so what we're expecting to do, one of the big ones that's missing and that we're expecting to release in 12.1 is increasing -N, number of users on the machine online. And then we have a couple of other small ones that we're going to do. Some of the caches, the encryption cache, security cache, and number of checkpoints, because those are little small ones we're going to be able to fit in the 12.1 time frame. Following that are going to be the server-based parameters, so MA, MN, and then along with PICA and MAX indexes. Well, we're looking at that by the end of the year. Those should be in 12.2. And the following three there, table range size, the statistics, will be on after that. I'm not going to say they're making 12.2. I don't know if that's going to fit in our schedule. They might, but it'll be there shortly after. In order to make this work and work seamlessly or more seamlessly, we are going to use our DB user notify or user notify mechanism that exists now to tell the clients that they need to connect to a new shared memory segment. Additionally, we're going to improve the current mechanism to make it more seamless in the deployment. The current mechanism right now, depending on how you have it originally set, the user notify, how you have it originally set, could be a little clunky, take a little longer than what you would expect if you want to change things to happen more quickly while things are online. If you have it set for a long polling period, it'll take a while in order for some of these things to take effect. So we're improving that mechanism as well as part of 12.2. And lastly, whenever I talk about these, this increase to, remember that allocating new shared memory segments requires all direct connections or self-service clients or servers to connect to these new shared memory segments. And in order to do that, they need to have these group security permissions the same as the .db file. Right? If your deployment is set up that way, then these new shared memory segments, once they're created, all your connections to the database will be allowed to connect and read and write to those shared memory segments. Otherwise, this increased to thing does not work so well. It has to wait for a reconnect. Okay? So we want that to happen seamlessly for you, so set up your security permissions properly. From the physical database maintenance side, one thing that we've, again, just put into the 12.1 release, which again will be released around August, is the ability to extend existing variable length extents, pre-extend them to a large size, as well as create new ones that are pre-extended to a large size. And why do we want to do this? There's a couple of reasons. At runtime, right, allocating space from the file system is very expensive. And you do this for not only your data extents, but also for your BI and your AI extents, if you're not running with fixed AI extents, right? So since that's so expensive, what we want to do is give you the ability to say, I want a variable length extent, but I want to pre-allocate a bunch of space from the file system for that extent. So this is going to, you don't have to worry so much about these variable length extents running out of space and causing the system to crash while the database is running. And if you fill up that fixed portion or that pre-allocated portion of the extents, then automatically it'll just start getting, just like it does today, like how a variable extent works, it'll just start getting space at runtime from the file system. The other thing that was cool about this feature is that if you do a truncate BI and you have pre-allocated a variable length BI extent, that truncate will remove the data in there, but not remove the pre-allocated space. So this pre-allocation persists across our A-image empty as well as truncate BI. And ProRest, the result of a ProRest or a ProCopy, the target, whatever is set on the target ST file, will do the pre-allocation for you. So it's completely integrated with all the other tools that we have. To give you a quick snapshot of a view of what this is going to look like, there are two flavors of this, and one is the E, this is a really small pointer, one is the E option, which says extend an existing extent. So if I've already got all of my AI files configured in my system and I want to pre-extend them so that we're not getting that space at runtime, I could use this E option in ProStruct in order to pre-extend those variable length extents. If I want to create new extents, I want to add a new extent to a storage area, I would use the X option to create a new extent that's going to be pre-extended. So you can do this both ways, on existing or on new. And all this can be done using ProStruct Add Online, right? In order to support 5.9s, we need to be able to do this while the database is running. We've also extended this for the V option. Does anyone here use the V option in their extents? So I don't know why we continue to support this. I asked this at all the presentations. No one ever uses this thing. So maybe it's something we should look at dropping. But we did integrate it with this new feature. So we will support an EV and an XV. And what that means is we will pre-extend it to the first value. So we pre-extend the extent to the first value. And then the V option is the second value, which means that's the maximum size we'll allow that variable length extent to grow. Other operational maintenance things that we're going to implement and roll out to support our 5.9s, this will be coming after 12.1. Plan for 12.2, end of the year. Index check performance improvements. The ability to do an index rebuild online. So we're going to do this through an index deactivate option. Will allow you to deactivate the index while your application is running, and then we can index activate that index, which will basically rebuild it and then put it back online for you. Now, there are a couple of pieces to this. You don't talk about alternate index at runtime.
I can if you want me to.
No, that's fine. So I don't know if you have a slide for it. That's all I was going to say. So the idea here is that while your application is running, it requires indexes, right? And if it requires an index that's been deactivated, how is the application going to run, right? I'm looking for everything in order, all my customers in order of name. Well, I'm going to use the name index, obviously, right? But if the name index is being rebuilt, how does that application going to continue to run? Well, the AVM is going to become smarter now so that it can choose an alternate index to run that query at runtime. So instead of using the name index, it'll see that the name index is in a deactivated state, and it will not use that index even though it's compiled in the R code. It'll automatically choose a different index to use and maybe have to sort. So what does that mean? That query might take a little longer to execute than it does if it's using the best index, but the application will continue to run while these operations are happening. So this is going to allow you to do an index rebuild online while the application continues to run.
What if they have use index in their queries?
The question is, what if they have use index in their queries? Absolutely no problem. We will choose the next best index. So the question is this for dynamic queries also? Yes, actually, it's easier for dynamic queries than it is for non-dynamic queries for us to implement. But yes, it will work for dynamic queries.
For dynamic queries,
we choose at runtime today anyway.
We choose at runtime anyway, so it won't see that the index that's deactivated, and so it'll choose a different one.
The question is, how do we handle unique indexes? Not sure what you mean. Not exactly sure, to be honest with you. I'm sure that's going to be taken into consideration, but I'm not exactly sure. So,
well, as the index is being rebuilt, that's what will validate that the index is unique.
Unique, but you're not querying on it. The insertion is okay, but not the query.
So, that's a good question. I'm not sure. I have to talk to the engineers that are working on the project. But basically, the other cost of this is that in addition to the fact that you might not choose the best index to use because it's been deactivated, we have to re-prepare the query at runtime, which is a small hit up front, but it is re-preparing the query. And so we'll try to choose a better alternate, the next best alternate index, and then like Rich said, he'll have to do sorting in order to match what the query required, according to the original index.
Over here. Yeah.
If there are no other appropriate indexes, is it possible that it will consider a table scan?
Yes, for type 2. So the question is, if there are no other appropriate indexes, will it choose a table scan? Yes, that is another option for things in a type 2 store, for tables that are in a type 2 storage area. We could use a table scan in order to gather data. Again, the sorting of that could be very expensive, but it will continue to run. Was there another question in the back on this?
Pretty much the same question. You only have one index on the table. Are you going to result in a table scan?
You will result in a table scan, and I'm sure that you'll see the performance hit. So add another index. Okay, so we'll move on. So the other part of this, right, is what happens for operating system upgrades? What happens for OpenEdge upgrades? What happens if I have some disaster on my machine? How are you going to support 5 nines in that environment, right, or that happens? Well, part of our, we have a described deployment, if you will, that we plan to support 5 nines with. And one of the things that described deployment has to have replication. It has to be running with replication. And this is going to allow you to fail over to your target machine. Now, we know that sometimes you have to transition, well, not sometimes, but you have to transition that target machine to a new source. And when you do that, you bring the database down, you say, oh, this is going to be a new source, it comes back up, goes through crash recovery, and then things can connect to it again. Well, that can take too long. So what we're doing is making it so that the target would automatically transition from a target to a source, to the new source, without the need to bring it down and back up again. Okay? And then we are planning, and Tim's going to talk about this, so I'm not going to go into it too much, but the idea is to allow the application to know where its targets are so it can reconnect and continue to run the application on the target. And Tim will talk more about that in just a minute. And lastly, there's some more stuff to come, right? In order for us to complete the 5 nines, that's what our original stuff is. I said we're gonna enhance the user notification stuff. We are gonna improve the BI space management. So you need the ability to not really truncate the BI file online, but prevent the BI file from growing ridiculously large by reusing clusters that don't have transactions in use associated with them. So to avoid the need to truncate the BI while the database is online, we will prevent it from growing very, very large, unless you have an active, really large transaction. Often, there's that syndrome where someone starts their data entry, creates a record, and then gets a coffee and comes back. And during that time, the BI file is going to grow, but that transaction really isn't actively writing additional notes to these new clusters. So we could take advantage of that and reuse those clusters as opposed to making the BI file grow. We're also going to improve the table and index move capability to be a reorg, an in-place reorg, so that you don't have that phenomenon of locking the table for update while the table move is being occurring. And let's see, prostruct move, all the other things that, all the other things you need to do to maintain your database are going to be done online. This last piece here is a pretty big piece. This is killing of a direct connected process to the database can bring the database down, right? So everyone says, do not do kill-9. You can die holding a latch or holding some other resources. So we're going to eliminate that from occurring. And so that actually is at the bottom of the list because that's a big project. We do expect there to be some performance impact for us doing this, but the way we're going to do it is there's a lot of latches right now that just protect data structures, and they want to look for information out of the data structure. They're really not changing a linked list, let's say, or manipulating a stack or a queue. So if they're not doing manipulations, if they're just looking it up, we're going to mark those as read-only latches, and if you die holding those latches, it's okay, right? Because you haven't really changed anything. It's not protecting something that's changing. Now, there are other latches that actually do changes, and what we're going to do is build a little in-memory BI for these latches. So we're going to know what that latch is changing so that if that process were to get killed while holding that latch, the watchdog or the broker, when they clean up that user, can undo what was done by that latch. And so recording of that data is going to cause a performance impact. We'll probably make this an opt-in feature. Any other questions about that? And excellent. So I'm going to hand it over to, I'm sorry, go ahead.
So Rich, you had a bunch of things. Were you increasable? Will you be able to decrease it as well?
So the question is, we have a list of things that are increasable. Are we going to allow them to be decreased as well? Currently, we have no plans to do that. It is easier. It is pretty easy to decrease them, but we're not going to give the shared memory back, right? We just won't. So back to the operating system anyways, and we could just put it in your MXS or something like that. So the long and short answer is we are currently not planning to do that. Is that something that everyone sees as a big drawback? Is that something we should put on our list? So
I'm also thinking of cases where you accidentally increase something much larger than you really intended to.
yes, so someone fat fingers an extra 0 on the increase 2 and it gets really, really large, you can't undo that. We'll take it under consideration is what I'll say. Yeah, it's currently not planned, but okay.
So just I want to get a sense here in this audience, who here is sort of an OpenEdge database geek? Don't be afraid. Don't be embarrassed. And who is when you think about the OpenEdge database, you think, I don't care about the OpenEdge database because it just works. Well, some of you, like I said, the point that I'm trying to make is that the lion's share of the 5 nines initiative of being able to only have downtime for 5 minutes and 23 seconds falls on the database. A lot of the work involved is in the database and in transitioning things and making sure that all just works, because it does just work. But there are a few things that need to be taken care of in the client, in the AVM. And so we're going to talk about those. First thing is online schema changes. As many of you are aware, the compiler boils into the R code an image of the schema And when it connects to when you are using that R code against a database, it wants to confirm that the schema in the R code matches the schema as it is right now. And there are a number of things that can't be changed online in the schema. And the reason that they can't be changed online in the schema is largely because of the runtime engines, the AVM and then the SQL client as well, the SQL server as well. And so we need to do work. That's the lion's share of the work for us on the AVM side, is making these things so that they can be changed online, and we keep the schema cache, which each of the AVMs has its own schema cache, keep that cache coherency up to date. So expected in 12.1, we're making some changes to allow you to modify things that you should have always been able to modify, and for some reason they were not taken care of way back when. Non-structural schema changes, things that are hints that are in the schema that are only used by the compiler, things like the label, _label field, things like that. Well, those are just a real nuisance, because if something changes, all of a sudden, when you apply those schema changes to your database, it requires an exclusive lock on the schema. So we're fixing that. We're going to allow you to change field data type from an integer to an int64. And we're also going to allow you to add, delete, update your database triggers, the schema triggers. And we expect that will be all done in 12.1. In 12.2, as Rich already mentioned, there's some database utilities work that's going on. One of the things is deactivating an index. Once the index is deactivated, and the database group has done the lion's share of the work on that, then the runtimes, it's a relatively small job for us to be able to then drop an inactive index and make sure that everybody, all of the clients know not to use the index because it's disappeared. We also are going to expect in 12.2 dropping a non-indexed field. So if a field is participating in an index, dropping it has great ramifications to the index itself, and so we're not allowing that. You first would have to deactivate and drop the index, and then you can drop the field. And also renaming a field is another request. A little further out, probably in 2020, the following year, these other schema change operations are planned. Renaming an index, renaming a sequence, dropping a sequence, renaming a table, dropping a table. Is there anything that's that you wonder if it's is missing from the list when you think about schema changes and allowing them online? Yeah. Well, large objects are fields. So it's a part of it. So that should be covered. Although it is a particularly difficult part. It's a special field. I'm sorry? Rich?
Yes.
That's a database thing.
In 2020. Yeah. Ish. Yeah. It's not part of our 12.1, 12.2. So we kind of talked about 12.1, right, coming out August timeframe. This is expected, so don't hold us completely to it. And 12.2 coming out by the end of the year, and we kind of have a good idea about what we can fit into those releases. Given our nice safe methodology, we have a very pretty predictable thing, which is really nice. That's what allows us to say this, right? Is that we have with pretty good confidence that we can fit these things in. And then there's a bunch of other stuff, right, that we really haven't scheduled and see when we can fit in, and that's what we're putting beyond that. So yeah, 2020, right?
So all these changes will work with the shared memory clients as well? For the character applications, we have shared memory clients, right?
Yes.
Yeah, so the question is, will all these work with shared memory clients, not just client server? Yes. Now realize that the kill-9 for non-client server clients is not going to be done until 12.2, right? So just okay.
Said 12.2?
12. I think I said
Yeah.
12. Yeah.
So, but yeah, certainly all the schema change work doesn't matter if it's networked or self-servicing.
So how does it typically work if we change schemas and recompile the R files that clients are already logged in?
We'll talk about that in a second. So basically the short answer, the question is, how does this work with clients that are already logged in and are already active and they're running an application, and then you've changed the schema and you recompiled and you want to redeploy, how does that work? We will talk about that. So in fact, did you read the slide? Deploying your schema changes. So making your schema changes online is one thing. Deploying your application, your updated application, is another. And we want to be able to make that as smooth as possible, limited downtime. So here is sort of outline a very kind of simplistic view of the steps that you might take to redeploy your changes, right? This should be somewhat familiar to most of you. Developers work on version 2 of the application. In this example, assume version 1 is up and running in production. You maybe make some schema changes to your development DB. You create a delta DF file that represents those schema changes. And then you apply the delta DF to your production database. And after you've done that, your schema has been upgraded to version 2. Version 1 of the application continues to run. Now, presently, there are only certain things that you can include in the delta DF file, right? Adding a table, adding a field to an existing table, adding a sequence, those kinds of things. But then step 4 is you distribute version 2 of your application and continue running, right? But so there are all of these restrictions because of the schema changes that prevent you from doing full changes and keeping everything running. So problems with this, first of all, is that the delta DF that is generated doesn't distinguish between those operations that can be presently done online and those ones that can't. And so they're all intermingled. You apply the delta DF. If you've made one mistake, you've got one thing in there that can't be done online yet, the whole thing needs an exclusive lock on the schema, and you're kind of in single user mode. This is not continuous operations. I know that some customers presently just will, having their Jenkins process, they'll strip out the drop operations, dropping a field or whatever. It's not allowed online. There's also a sort of a little bit of a catch-22 with if you use database triggers. If you have R code that you've updated and you've added some triggers and you've updated your application, your database trigger R code may actually depend on the schema changes to have been made before it can run, right? But as soon as you apply the trigger code, the trigger changes to your schema, the code needs to be in place so that it can run. So you need the schema changes may be needed before the trigger R code can run, but the trigger R code must be present before the trigger schema can be applied. And so it's a little bit of a catch-22. So we're going to talk about our plan for a slightly modified process for how you deploy applications and apply your schema changes. A third problem is that destructive schema changes, even if you could do them online, they might disrupt your presently running application, right? Version 1 of the application may reference tables or fields or indexes that have been deactivated or dropped or whatever. And what is the application going to do? Well, it's going to fail. Lenovo system update. I don't think that's what we want to do right now yet, Rich. And so this is the proposed new approach that we have planned. Is that again, assume version 1 of the application's in production. Developers work on version 2. They make schema changes, and then instead of creating a delta DF file in its current form, a single thing, it'll be a 4-part. It'll be a 4-part delta. There'll be a pre-deploy section. This will have all of the common things that you can already do online and that you will be able to do online as we enable more capabilities. These are non-destructive changes, so they're typically going to be additive things. There will be a trigger section with all of your trigger schema changes, and then a post-deploy section that'll have all of the destructive changes. Okay, things that you're taking fields, indexes, tables away, that kind of thing. And then there will be an offline section. This will be a hopefully ever diminishing set of operations as we continue to march toward allowing everything to be online. But these are the things that you can't do online, and so you wouldn't want to apply this section to your database without, you have to bring it into single user mode to do that. So so you create your 4-part delta. The next step is to apply the pre-deploy section of the delta DF file. Version 1 of your application continues to run. It doesn't know anything about the new tables, the new fields that you've added. It just operates. Step 4 is then you deploy your updated database trigger R code. So the database trigger R code, if it depends on the schema changes that were applied in the earlier step, that schema will already be there. So these triggers are ready to run as soon as you activate the triggers. Optionally, step 5, you might run some batch process to populate your new fields or tables. Actually, you could do that as step 4. You could switch those around. It doesn't matter the order. Step 6 is you would apply the trigger section of your delta DF file. Okay, as soon as you apply the trigger section, all of your triggers are going to be activated and are going to begin to run. You're currently running AVMs are going to recache their trigger information as soon as they finish their current transactions, and they'll begin to use your new triggers. And then version 1 of your application can continue to operate in this world. It will run the new triggers, which is why you need the trigger code to be available and deployed. Then finally, deploy version 2 of your application R code, and while version 2 of your R code is running, your AVMs running version 1 can continue to operate. They can continue to run version 1 of your application. This is sort of has step 8, but it's really a part of that previous step. Your version 1 of your AVMs need to migrate over to version 2, and there are ways, given our time today, we're not going to go into the details about how that can be done, but especially with the PAS-away app server, there are some techniques for upgrading the application, having both versions of your application running, and put a load balancer in front of it, and all requests that were going to the version 1 of your application now get rolled over to begin going to version 2 of your newly deployed application. You don't have to use containers. There are other ways to accomplish that with PAS-OE. The AVM clients basically need to be restarted, would need to be restarted. You might do that by restarting them, resetting a pro path. Then finally, once you're confident that version 2 of your application is what is running and has displaced version 1, you can apply the post-deploy section of the delta DF. Now, if you know that your application is not using the things that you're dropping from the schema and from the database, version 1 isn't using those things, you can apply this sooner. As soon as you're confident that version 1 doesn't care about these schema artifacts. And so the benefit of this new process is that continuous operation of the application. Yep. All right. So that's just a slide. You can get these slides afterwards. Gives kind of a recap of the steps. I want to talk briefly about failover during replication transition. So here's a kind of a picture of OpenEdge replication topography. I can't tell if the pointer is pointing at anything. Can you see it? There it is. Okay, here's your host machine with your source database. It's got a primary target identified in the replication properties file. Here's host C was identified as the primary target. So the replication server here is talking to the replication agent down here, and the database is being kept in sync. The targets are read-only. Remind you, they are read-only, but you can have read-only access to the replication target, right? And so for transitioning from a source to a target, our focus is going to be on remote clients, because if you're a shared memory connected agent, client, talking up here, and this database goes down, we're not going to be able, the host is down, or you can't get over here without a network connection. So we're going to focus on these remote guys. And so the plan is that the application will be able to recover from a planned or unplanned transition. And the approach that we're taking is that the database replication servers will communicate with the remote clients and notify them about the stages of the transition. The AVM clients will auto-transition to the new source, the target that is going to become the source, and then the ABL application will be restarted. All right? That's kind of an overview. So here's just pictorially, you see the remote connections. They are talking here. They will establish a connection to the target servers. So these are just some of the notifications that the replication server will give anytime the primary transition target changes, because the clients need to know what is the target that is going to be failed over to. It needs to know when a transition has been scheduled, when it has started, and when it's complete. The AVM client context, what will be transferred from the source of the target is just the database connection, the login credentials, so it's login, and then it'll hold on to the schema cache because that'll be identical. It won't be able to transfer the transactions, record locks, open queries, and cursors. Those will have to be reestablished. Okay, but we're talking about doing that as quickly, restarting your application. So when the transition is scheduled, the AVM will establish a read-only shadow connection to the target. So it'll pre-establish that connection, so it can be done quickly. As soon as that replication target becomes the source, we'll be able to, and the transition is complete, the AVM client will be able to proceed. So when it gets a notification of the schedule, it'll establish this connection, but it'll maintain the source database connection until it gets notification that the transition has started. Does that make sense? As soon as it gets notification that the transition has started, that's in effect a database disconnect. And we will disconnect, the clients will disconnect from the source, and they'll do the things that they do whenever a database disconnect happens, which is persistent procedures that depend on that database, objects, dynamic queries. Those things will be deleted, and a stop condition will be raised. Okay, this is just what happens when you lose a connection to a database in the AVM, and that's what's going to happen. When the database server notification says, hey, the transition is complete, then the shadow copy, the shadow connection to the database target becomes the source database, and then the AVM will raise the untrappable stop becomes a trappable stop, and your application can catch that and respond to that. And you may not respond to it, you may just allow it to go, which will start the application will resync at that point. Fail over, fail back? Yeah, it's a good question. Can you fail over, fail back? Remember that yes, you can. That when the client transitions from the source to the target, which becomes the source, the new source, now that's its source. Okay? And so if a transition gets scheduled on that, the AVM is going to follow it back. Does that make sense? So it'll operate. It's the new source.
What version is that available?
We are targeting this for 12.2, so the end of this year. Other questions? There's one more little piece to the puzzle, and that is what happens to new clients that are connecting to the database. They go to connect to the database, and they see that the source is no longer a source, it's a target. Will allow you to, and it isn't connected to the source, and so it doesn't know necessarily how to connect to the target. And so we'll provide a new option following the -db parameter settings. DB alt, you give it the what would be probably your replication target, its host, and its port. And you can specify multiple of those in case you have two targets. I think we're out of time, aren't we?
Yeah, we're just over time, so I apologize for that. If there are any questions, you can ask afterwards or catch Tim and I in the hall. We don't want to keep you from getting to your next session. So I just want to thank you. Enjoy the rest of the conference.